3k plus. All right. So, first problem. So y equals 1/2 cosecant 2 theta plus 3 pi over 4 minus 2. I'm fairly certain that on WebAssign you are only asked to give the period on the cosecant or the secant graphs. I haven't really looked at the tangent and cotangent, but I did look at some of these, and I know they only ask you for period. Okay, so what we're going to use to help us graph these are the parent functions for sine and cosine. And so if you are comfortable doing sine and cosine, and you can add in like 2 more additional parts, this is really easy. If you're still struggling with sine and cosine, then you've got some catching up to do. And last period, the light bulb came on for third period with the fractions, doing the intervals, and man, they got it. And so hopefully we'll be able to do that today. Because it is time consuming for you to keep having to go to the calculator and put all that stuff in and then hit the amount fraction key. So hopefully we can do some common denominators to make this easy. Okay. The thing that I like to start with first is the vertical shift. So what's the vertical shift? Down 2. And then I'm going to go ahead and get my grid on here. I'm going to leave amplitude empty for right now. When we're finished with the graph, you'll understand why. I'm going to look at everything else. What is midline now is y equals -2. And then I do see an a value. What is the a value? 1/2. So I can apply that to a max and a min. So if it was -2 and I add a 1/2.
Or 3%.
So,
Or no, 5%.
well, let's add. Let's go up first. -2. -3/2. So y equals -3/2. And then the minimum would be y equals -5/2. So far, nothing's different. I still applied the amplitude to the max and the min points on my grid. All right, period is still the same. Because we're using sine and cosine to actually graph these, we can still use the fact that the period is 2 pi. So 2 pi over 2, because 2 is b, and so that gives me a period of pi. All right, my phase shift is positive or negative? Negative. It's the opposite of the argument. And so I'm going to do this up at the top just to make sure, because I really need for everybody to understand how to do this. I'm going to take 3/4 and divide it by 2. Well, that's really 2 over 1, which is 3/4 times 1/2. And so the phase shift is -3 pi over 8. -3 pi over 8. The pi back. Okay, so we have everything we need to do the grid. What is it that gives us the starting point? The phase shift gives us the starting point. So my starting point is -3 pi over 8. Okay, true or false? My ending point is pi. False. My ending point is period plus phase shift. So if the period is pi and the phase shift is -3 pi over 8, I can do this in my calculator, but wouldn't it be easier to just make pi 8 over 8? And so if I do that, 8 over 8 and -3 over 8, so this should be 5 pi over 8. Again, if that was just, mind blown, go to your calculator. It's okay to use your calculator. Don't let fractions keep you from doing calculus. Okay? So half, half, and half. Now, how do I know how wide to make my intervals? Period divided by 4. period divided by 4 gets me my interval width. So you know how if we're in the calculator it says x scale? The x scale is your period width. Okay, so pi divided by 4 is pi over 4. Okay, so if I want to do this the easy way without having to use my calculator, I'm going to make pi over 4 a fraction over 8. 2 over 8. So negative 3 over 8 plus 2 over 8 is negative pi over 8 plus 2 over 8. Positive pi over 8 plus 2 over 8. 3 pi over 8. And let's do that one last. Plus 2 pi over 8 gives me pi over 8. Again, if that is something that you're just not comfortable doing, put it in the calculator and then hit your math fraction key every time. How many of you understood changing that denominator and doing that? I just think it's an easier process to do it that way, but if it's too much, put it in the calculator. Okay, so now here's what we have to do. We're changing gears now because we're really not graphing sine or cosine. We're really graphing cosecant. So what is the reciprocal of cosecant? So out here I'm just going to put think sine. That's how you spell it, by the way. S-I-N-E. We abbreviated S-I-N. I don't want to write think sin on the board. Okay, so if I was going to graph sine, where does sine always start? At the midline, always, no matter what. And there's no reflection. So what happens first? Max, mid, min, mid. Okay, I'm going to do this two ways. The first time I do this, I'm going to sketch in the sine graph using a dashed line. The second time I do it, for the next example, I'm not even going to do that much. But I want you to see how I'm using the reciprocal function to graph the cosecant graph. So if I'm only using the sine graph as a way to get to cosecant, then it's really not there. And in math, how do we denote something that's really not there? We use a dashed line, and so that's what I'm going to do here. Now, if you have a pencil and you're doing this, what you could do instead is just do it in pencil and just do it real light, so that you can barely see it. Okay? Because we're just using that as a guide. All right, now, if you would look at the board here for a minute, and I've got the quadrantals drawn. And I've got 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay. Can you anticipate any place on here that might give you an answer that would be undefined for cosecant? If cosecant is the reciprocal of sine, and sine is y over r, then the reciprocal would be r over y. And if I do that at 0 or 2 pi or 180, I get an undefined answer, right? What happens when you get something undefined? What does that create? It creates a vertical asymptote. So everywhere I see a point at the midline is going to be one of those occasions in the graph. And so what I'm going to do is sketch in a vertical asymptote at all the midline points. So where's your first midline point? Negative 3 pi over 8. Okay, so I need to see your asymptote. So this has to be something that you do like maybe in a red pen or dark in a pencil or something like that. I'm going to sketch them in. They're dashed. They're not real. They're asymptotes. They're guidelines. Are there any other ones on here? There's another one at pi over 8. And another one at 5 pi over 8. Now we get to the actual cosecant graph, which I think if you've looked at WebAssign you may have seen before. What we're going to do is find the max and the min, or the peak and the valley on the sine graph. Where I have a peak, I'm going to draw what's called a branch upwards. And where I have a valley, I'm going to draw a branch downwards. So actually, the cosecant graph is nothing but those two green branches. That's it. That's all you should see. And on WebAssign, it probably is all you should see. I don't know. Does anybody know if they do asymptotes? Have you looked at it enough to know? I don't think so. So now when we were graphing sine and cosine, we said that you could tell you had gone a period if you saw a peak and a valley. So a peak and a valley. How are you going to know that you've gone a period on a secant or a cosecant graph? You're going to have one branch that opens up and one branch that opens down. So I have gone one full period here.
Yes.
Okay? And that's it. So now we need to address amplitude. So if you remember over here, by definition, amplitude is the distance from the midline to the max, or the midline to the min. Think about the branches. If it's opening upward with arrows on either end, what does it not have? It doesn't have a max. What about this? It doesn't have a min. Therefore, there is no amplitude. Actually, the only two trig functions that have amplitude are sine and cosine. None of the other trig functions have amplitude at all. We use that a value, though, to get the maximum and the minimum points so that we know where to put the maximum line and the minimum line, but it really doesn't have an amplitude unless you're talking about sine or cosine. All right, any questions about this one? It's pretty easy. You see what I mean? If you can graph sine and cosine, this is not too bad. Where do you put your asymptotes? At the midlines. So, in other words, if I were to take negative 3 pi over 8 and plug it into this formula right here, the answer that I would get would be undefined. If I were to take pi over 8 and put it into this formula, the answer that I would get for y would be undefined. So that's why I draw the asymptotes there. It wouldn't happen here. If I put in negative pi over 8 into that formula, what would I get? Negative 3 halves. If I put in 3 pi over 8, I would get negative 5 halves. Those do have values. But points at the midline just so happen to be undefined. I was trying to... And this one, I want to make negative. So this is negative 1/2 cosecant theta over 3 plus pi over 4 and plus 1. Anything that I can do quickly? The vertical shift is of 1. Okay, so let's start out at y equals 1. And then what do I do? I know the amplitude is in A. I could go ahead and fill that in now that I know. But how do I get the max and the min point if there's no amplitude? I'm still going to use the A value. What is the A value? It's 1/2. And so if I add a half, where does that put me? 1.5. So y equals 3 over 2. And if I subtract a half, y equals 1/2. Awesome. Okay, anything else that you notice? Do you know what the period is? What's the formula for finding the period? Period equals 2 pi over b. What is b? b is 1/3. So it's 6 pi. That's right. It's 2 pi over b. So 2 over 1 divided by 1 over 3 is really 2 times 3, which is 6. Okay, now what? Phase shift, positive or negative? Negative. Okay, so it would be 1/4 divided by 1/3. 1/4 divided by 1/3, which is really 3 pi over 4. Okay, so So I start at the phase shift with negative 3 pi over 4. And I'm going to finish at 6 pi. True or false? False. I'm going to finish at negative 3 pi over 4 plus 6 pi. So let's see if we can do this. How can I make an equivalent fraction for 6 such that the denominator is 4? 24 over 4. Will that do it?
Yeah.
Okay. 24 over 4 minus 3 over 4 is 21 pi over 4. And again, if that is too much for you to handle, that's okay. Put in your calculator. 6 minus 3/4. Make sure 3/4 is in parentheses. Math fraction. You should get 21 pi over 4, or 21 over 4. Okay, so now we have to divide it into 4 equal parts. So my period is 6 pi, and if I divide that into 4 equal parts, what do I get? 1.5 pi, so 1.5, right? So 1.5 is really what? 3 over 2, correct?
Yeah.
But I need to add it to something that has a denominator of 4. So 3 over 2 is really
6 over 4.
6 over 4. Okay, so negative 3 plus 6.
3 over 3. 3 pi over.
So I'm back at 3 pi over 4.
Yeah.
Plus another 6 pi over 4. 9 pi over 4. Plus another 6 pi over 4. 15 pi over 4. Let's double check. Plus another 6 pi over 4 puts me at 21 pi over 4. How many of you are able to do that with changing the denominator of the fractions? That's awesome. If you can't, that's okay. Put it in your calculator, hit math fraction. As long as you get it correct, we're good. All right, so anything else that we need to know to get started on this?
Oh, you're asking. Or,
Well, let's graph it first. I've got cosecant, right? Well, what's the reciprocal for cosecant? So I'm thinking sine, but I'm actually thinking the reflection of sine, right? Because I've got the negative. So sine graph always starts at the midline, but since it's a reflection, instead of going up, I go down. So here, midline, max, midline. Now on this one, I'm not going to draw in the sine graph at all. You can if you want to. All right, what do I do next? I need to draw in the asymptotes. Where do the asymptotes go? At the midline. So I have one here. Where's another one? 9 pi over 4 is another one. And the last one? 21 pi over 4. And now I finally get to the actual graph I'm looking for. What do I do? Draw my branches. So I have one branch that goes down and another branch that goes up. Okay, now compare this graph to the one that you did previously. What's different about it? They're just switched. The branches are shifted. One went up while the other one went down, and then vice versa. That's because one sine graph was positive and one sine graph was negative. So this is easy if you know how to graph sine and cosine. Yes, ma'am. Okay, so the A value in here, go back up to the problem, is right here. And it's always absolute value. And that's how we get this and this. Any other questions before I move on? Because we've done 2 cosecant, and so the next 2 that we do are going to be secant graphs. And I think 4 is enough. But if you need to see more, then we can make up another. Okay, so this is really the secant. So y equals secant of beta over 3 plus 5 pi over 4, what's your argument, minus 1. Anything easy to start with? Vertical shift down 1. Okay, so y equals -1. Okay, do you see an A value in this problem? It is an understood 1. In algebra, we just use the understood 1. So from -1 up 1, that's y equals 0. And from -1 down 1, that's y equals -2. Okay, anything else? Can we go ahead and put an A for the ant? Okay. All right, period. 2 pi over 1/3, which is 6 pi. Phase shift, positive or negative? Negative. Okay, what's your question?
How do you know? Oh wait, never mind. Since there's no left, okay, never mind.
You good?
Yeah.
Okay. All right, so I've got 5 over 4 divided by 1/3, which is really 5 over 4 times 3 over 1. So negative 15 pi over 4. And that is my starting point. And so how do I find my ending point? Phase shift plus period equals end point. So we did this last time. 6, if I make it an equivalent fraction over 4, is really 24 over 4 plus minus 15 over 4. 9 pi over 4. We're good with that? Okay. If we make a mistake, we'll know it. When will we know it? When I start graphing it, it's going to look weird. And when I get to the end, I'm not going to end up where I need to be on this scale. So if I take 6 pi and I divide it into 4 equal parts, that gives me 3 pi over 2, or 1.5. 3 pi over 2. How do I turn that into an equivalent fraction with 4? 6/4. So 6 pi over 4. So this negative 15 plus 6. Negative 9 pi over 4. Plus another 6. Negative 3 pi over 4. Plus another 6. 3 pi over 4 plus another 6. There you go. 9 pi over 4. That's perfect. Yes, ma'am. So I take period divided by 4. To find the interval, we do period divided by 4. And why do we do period divided by 4? The quadrantals, 4 quadrants. Unit circle is divided into 4 pieces. We want to divide our graph into 4 pieces because that's how long it takes us to make one full revolution. Okay? All right, so I'm graphing secant, which is really the reciprocal of cosine. So I'm going to think cosine. Okay, cosine graph starts at the max. So max, mid, min, mid, max. I don't need to sketch that in, but if you want to, go ahead. Just make sure you sketch it in with a really light pencil mark or with a dashed line. All right, what next? I need asymptotes. Where do I put them? At the midline. So where's the first one? Negative 9 pi over 4. There's one. And positive 3 pi over 4. There's another. I'm going to move this up. This one looks different, doesn't it? So if I start at this minimum point, I can see where that full branch goes. Can you? I'm going to do this. That looks good to me. Where's the other part?
It's like half.
It does. I'm going to get half on one side and half on another. So from here, I'm going to go up and to the left. And on this one, I'm going to go up and to the right. And when you put those two together, you piece them together, it makes the whole branch. So you still have a whole branch that goes down and a whole branch that goes up. Bless you. Just like cosine. Remember on cosine how we could clearly see the minimum, but we couldn't see the full maximum? We had to pair up two pieces. Same thing for this graph. Yes, ma'am. I always put the asymptotes at the midline because it just so happens that if I were to put negative 9 pi over 4 into this equation, if I put in secant of negative 9 pi over 4 divided by 3 and added 5 pi over 4 and then subtracted 1, my answer would be undefined. If I put in negative 15 pi over 4 and did all this to it, kind of like an input-output machine, what would my answer be? 0. It's an ordered pair. They're all ordered pairs. So this is like your x value. Your angles are like your x values, and then your y is your y value. So when you plug it in, it just so happens that values at the midline become undefined. And so that's where we sketch in our asymptotes. We got one more. Let's make this one negative 2. And this one we're going to do in the calculator because I want you to see what it should look like and how you can use your calculator to help you with those multiple choice questions on WebAssign where they give you the graph and you have to pick out the right one. If we did not answer amplitude on the previous one, go back and put what? NA. I think we left it blank, so let's do that first. NA, no amplitude. Amplitude only on sine and cosine. All right. What do you see? I see that vertical shift. I like starting there. So this would be y equals 2. And how do I get the max? The A value is, well, it's actually absolute value. You're right. A is negative 2, but I take the absolute value of that to get my max and my min. So I'm going to add 2 and subtract 2. So this one would be y equals 4, and this one is y equals 0. Okay, anything else I can do? Period is pi. So phase shift is, so it's negative, so I've got 7 over 4 divided by 2, which is really 7 over 4 times 1/2, which is negative 7 pi over 8. Is it getting better? The whole fraction issue getting a little bit better? Okay, good. So we have everything we need to start my grid, and so I'm going to start at negative 7 pi over 8 plus pi, which is 8 over 8. See, I like the way you're thinking. 8 over 8 minus 7 over 8.
Pi over 8.
That's where I'm going to finish. Pi over 8. Okay, so my period is pi. Period divided by 4 gets me my interval. So it would be pi over 4, but you're already thinking ahead. This is over 8, so we might as well make that over 8. Pi over 4 is really 2 eighths. So negative 7 eighths plus 2 eighths. Negative 5 pi over 8. Plus another 2 eighths. Negative 3 pi over 8. Plus another 2 eighths. Pi over 8. It's got to be negative. How did you know it was negative? That one was already pi over 8. You weren't there yet. Now add 2 eighths again and pi over 8. Now we're good. Okay. This is secant. Secant is the reciprocal of cosine. So I need to think cosine. Got it. Okay? But it's reflected. So it starts at the minimum. So I've got a minimum, a mid, a a max, a mid, and a minimum.
You gotta do your ass.
Got to do the asymptotes, and where do they go?
The middle.
At the midline. Negative 5 pi over 8. Negative pi over 8. Now what?
Draw your, what are they, branches?
So I've got a branch going up right here. I like this one. That one's easy to see. Let me get a little bit more screen here. This one goes
To the right.
that direction, and this one goes that direction. And now I have one branch going up and two halves that make a whole branch going down. So it's different. It went in the opposite direction of the previous one when cosine was positive. This one is cosine is negative, so it's just split. Now tell me again why we choose the midline values to draw asymptotes. If I plugged in that angle measure, it would give me an undefined value, which means that 0 would end up being in the denominator. So it means that since it's cosine, it's got to be some rotation of pi over 2, right? It's got to be some rotation of pi over 2. And then again. And then again. How many times I make that rotation? Anytime I get there to that particular interval, I'm going to end up with a value that's undefined. Okay. Questions about sine, cosine, secant, or cosecant? I sure can. As a matter of fact, let me do this. And this on here. Insert. Okay. So Haley wants formulas. You want formulas for finding period and phase shift? How about if I do this? How about if I started out like this? Y equals plus or minus A, and then we've got trig function. I'm just going to use sine. Parentheses B theta. So plus or minus C, actually C with pi, and then plus or minus D. And you know this applies to any of the trig functions. The only thing that's going to change is when we get to tangent and cotangent, the period is no longer 2 pi divided by b, it will be pi divided by b. And that, so this is, for right now, what I'm doing for you right now is for sine, cosine, secant, and cosecant. Okay, so, period. 2 pi over b. Amplitude. It's just the absolute value of A. Phase shift. So it's really negative C over B, and that helps us determine which direction it moves. If it's positive in the argument, then we move in a negative direction and vice versa. Okay, and then I gave you two kind of equations to use. I said phase shift plus the period equals the end. Phase shift plus the period equals the end. And then we had period divided by 4 equals interval. What else can we think of? Vertical shift is just going to be whatever D is, so plus or minus D. And the vertical shift is actually the midline. Okay, so how about if we add in for secant of theta and cosecant of theta, where do we put the asymptotes? Asymptotes at midline. Asymptotes at midline.
And secant and cosecant never have an amplitude.
That is correct. No amplitude. So this is like a little special box right here. No amplitude. The only trig functions that have an amplitude are sine and cosine, nothing else. Anything else you can think of that we used a formula for? Other than just the fractions and converting them to something with a common denominator, making it much easier than having to put it in the calculator. All right, I want to do that last problem in the calculator because I really want you to see what it looks like, especially those of you who have an older version of. Okay, this is what you need to put in to y equals for the problem that we just did. And whenever possible, if I possibly can, I'm going to put a decimal into these because otherwise I end up with so many parentheses that it just gets. I end up with a lot of syntax errors, so I just put everything in decimals if I can. So -2. Now, why did I put in 1 over cosine? It's the reciprocal of, what did we just do? Secant. So you notice on your calculator, you don't have secant, cosecant, tangent, you have tangent, you don't have cosecant. So the reciprocals, you have to do 1 over the parent function. Okay? Not inverse. Inverse is something totally different. We'll do that next week. Okay? So put this in your calculator, and then let's go to the window and adjust the window so that it looks like what we just did. Got the equation in yet? Good. All right, window. Can you tell me how I got that x minimum value? What is our x minimum? Whenever we do these graphs, our x minimum is the phase shift.
I was gonna say.
Yeah, our x minimum is our phase shift because that's our starting point. So if we want the calculator to show us a graph that looks like what we have, then we want to start it where we started it, which is at the phase shift. Now obviously I put the pi in there so that I got an irrational number. And then how do you get the x max? It's our ending point. What was our ending point? Okay, so that's what you put in. And then scale refers to the interval width. What was our interval width? Wasn't it?
Pi over 4.
So pi over 4. So put in pi over 4. And then I set my y minimum to -4 and my y maximum to 10. And that's just because these kind of go on forever. So I want to be able to see what I'm doing. Really and truly, if you set these to, let's see, I could actually set this to -10 and +10, and it would give me a pretty good picture of what I need to see. Okay, so, how'd you get that? Well, what was your interval width? Period divided by 4. Period divided by 4 is your interval width. That's your x scale. Okay, interval width is your x scale on the calculator. All right, so I hit graph. Does that look like ours? Looks like the shape of ours. We had 2 pieces, half pieces, and we had a whole piece in the middle. Okay. If you have a TI 83 or 83 plus, do you see a whole lot of lines in yours that are just really confusing? So you might have that issue. Saying you see a lot of lines. So what happens is this: with the older calculators, the operating software is just not as advanced as in the other ones, and so it doesn't know to put the pin up. Those are really not asymptotes. That is a fault of basically the operating system, the software. Okay, so don't think those are asymptotes, they're really not. If you look at a calculator that's maybe like a TI 84 or higher, they fix that little glitch. Zion, bring your cash calculator. I know if you don't have it, that's great. But if you do, I wanted you to see it and be aware of it and know that it was just an error in the software, not your calculator. You have to plug in what I have on the side. According to your graph, or else you're not going to see what we graph.
I have a charger.
So it's not really
You have to
So the one, so the extra minimum is